In this video, I'm going to attempt to explain motional EMF, which is the EMF induced by a conductor moving through a relatively or essentially constant magnetic field. So what we have is a bar, or let's pretend this is a perfect bar, and it's moving through a magnetic field, all of which are just X going into the page. It has V. When this conductor is going through the field, it'll create an EMF inside of this bar, or which in turn will create an electric field inside of this bar. And that's because there'll be a change of potential across it. This happens because, as you know, positive charges and negative charges are differently charged. So you'll have negative charges build up on one side and positive charges build up on the other. This is because inside the magnetic field they'll experience a force called the magnetic force, which I covered in a previous video, which is equal to Q V cross B. And because one is negative and one is positive, they will move to both extremes. So I think it would actually be flipped, and the negatives would, or the positives would be up here, the negatives would be down here. But essentially it's the same. There'll be a potential difference across it because this could either be positive or negative. And both of these have to be the same for both positive and negative. So there'll be one force pushing all the electrons up, one force pushing all the electrons down. And then because there's positive charges on one side, negative charges on the other side, there'll be an electric field created between both of them, which induces an EMF. Which the motional EMF is equal to the negative. This is from a previous video. This is from Faraday's law, which is equal to, which I also went over in Faraday's law video, which I recommend watching. This right here and X will be, in this case, will be the position of the bar moving along this way. So this is X. L will be the length of the bar. V is obviously V. B is the magnetic field. E is the EMF. And like I said, this all comes from Faraday's law, and the relation between electric field, EMF, magnetic field, and this force, the magnetic force equations. I don't want to go through all that because it's going to take a lot of time, and I don't think it's really worth it. But to kind of show really quick what this means is that all these are going to be related to each other, which you could divide the r's over, and these r's get canceled, or multiply this r over, the r's get canceled out, and IR will equal the EMF, which will equal BLV, which again, right there. So it follows Ohm's law, because this is Ohm's law right here. And the final step in proving it is that power is equal to the force applied over a specific time period times velocity, or yeah, whatever. That'll give you power. And then you have this equation, ILB is equal to the force, and there's still V in there, which will equal B squared, L squared, V squared divided by R, which is equal to the EMF squared divided by R, which in a previous video over power, this equals power. So all of Newton's laws are maintained here. All the laws of previous physics were still maintained. So this is just a way of proving that an EMF is actually created, though I'd recommend just going back and listening to the explanation I gave at the beginning about how the electric field is created across it, and that it creates a potential difference across it, which is an EMF. So basically, go over this explanation. How this can be used is the force of the magnetic field and the force applied due to current will eventually equal themselves out. So this will be force applied. So if this right here, if this is on like part of a circuit, let's say we have a battery right here, there'll be an I going this direction, perhaps, and you then have to set this right here, circle it in red. You have to set this equal to, actually, this will be the force applied right there. You can scratch out that V. And that has to be equal to the magnetic force right here. And when those two equal each other out, that'll be your velocity moving down this particular loop, which can change over time. That's a more advanced, well, I think more advanced physics question, and I know I didn't cover it too well. If someone comments, I'll be happy to help you. Right now, I was just trying to show you the basic concept and why it works like that. If you need help with these problems, feel free to comment, and I'll help you out, or perhaps create a new video if you ask. Thank you.